Hello to the people figuratively inside of the internet. I am going to be reading Chapter 3 of Crafting Interpreters, the clox language. What nice thing can you do for somebody to make them breakfast? Anthony Bourdain. I have no idea who this guy is. Chef, okay. We'll spend the rest of this book illuminating every dark and sundry corner of the clox language, but it seems cruel to have you immediately start grinding out the code for the interpreter without at least a glimpse of what we're going to end up with. At the same time, I don't want you to drag you through the realms of language lawyering and specificationese before you get in touch with your text editor. So this will be a gentle, friendly introduction to clox. We'll leave out a lot of details and edge cases. We've got plenty of time for those later. Okay. So a tutorial isn't very fun if you can't try out the code yourself. Unless you don't have a clox interpreter yet, since you haven't built one. If you're not, you can use mine. So he's going to have... Remember looking at a list of clox implementations. So you can do that. Yeah, so I can just build and make it, and then I can run the interpreter from the root of the repo. That is pretty cool. I don't know if I... DNF list installed make. Can I have make installed? Yep, cool. Make book, okay, cool. Yeah, so I will keep this in the back of my mind for later. Hello, clox. Here's your very first taste of clox. Print hello world. As that / line comment and the trailing semicolon imply, clox syntax is a member of the C family. There are no parentheses around the string because print is a built-in statement and not a library function. Okay. First is a clox language that I don't know if you've ever had cured cold smoke SAML before. If not, give it a try too. That is, I don't know. Now, I won't claim C as great syntax. If we want to make something elegant, probably mimic Pascal or Smalltalk. We want to go full Scandinavian future minimalism, we do Sheen. Those all have their virtues. Okay, well, I'm actually going to get this running right now. Once I can do that, run make. Make clox. Build clox is already up to date. Build, then clox. Okay. Beautiful. That was so much effort for this right here, right now. Okay. I'm gonna pause the recording, get some water, I'll be right back. Okay. Back to it. So let's see. Print hello world. Cool. That works. I just spent like 30 minutes trying to install Flutter or Dart because there's no package on Fedora, going through snaps and then going through version errors. And I totally could have just typed make clox right here and didn't have to download all of the like JavaScript and stuff, because this repo does like everything for websites, all of it. So I didn't think through the issue, and I could have saved myself some time. So yeah, next thing is next. Now C, those are pretty biased. I think that's clox syntax is pretty clean. C's most egregious grammar problems are around types. Dennis Ritchie had this idea called declarations reflect use, where variable declarations mirror the operations you'd have to perform in the variable to get a value of the base type. Clever idea, I don't think it worked out in practice. I don't get it. What does int pointer to, is that a cast? Int C. They made a program to help people understand the C syntax. If I were designing pointers, I translate a pointer to a 10-element array of pointers into, and not int star, and then a reference, and then what? And that is this is the variable name. This is the dereference operator, but in this case it's using to sort of declare a variable. So a reference to p10. Syntax variable centric rather than type centric. Okay. Look at the declaration and think, if I write the expression starfunc arg, that will result in an int. If I write I'll have a float rather than a func. I'm not reading all of that, but that does make sense. All the way in my head, not quite. It seems like syntax has instead is something you'll often find more valuable in a language. Familiarity. I know you're already comfortable with that style because the two languages will be using equivalent clox. Java and C, also inherited. Using a similar syntax for clox give you one less thing to learn. Well, this book ended up being bigger than I was hoping. It's still not big enough to fit a huge language like Java in it. In order to fit two complete implementations of clox in these pages, clox itself should be pretty compact. When I think of languages that are small but useful, what comes to mind are high-level scripting languages like JavaScript, Shim, and Lua. Of those three, clox looks the most like JavaScript, mainly because of the C syntax languages. Mainly because most C syntax languages do. As we'll learn later, clox's approach to scoping is closely to Shim. The C flavor of clox we'll build in part 3 is heavily indebted to Lua's clean, efficient implementation. Yeah, Lua's a cool language. Now that JavaScript has taken over the world and is used to build... Is that really how you spell ginormous? That is not how you spell... That is how you spell ginormous. It's hard to think about... It's hard to think of it as a little scripting language. But Brendan Eich hacked the first JS interpreter into Netscape Navigator in 10 days to make buttons animate on web pages. JavaScript has grown up since then, but it was once a cute little language. Because Eich slapped JS together with roughly the same raw materials and time as an episode of MacGyver, it has some weird semantic corners where the duct tape paper clips show through. Things like variable hoisting dynamically bound to this, holes in arrays, and implicit conversions. I had the luxury of taking my time on clox, so it should be a little cleaner. Clox shares two other aspects with those three languages. Clox is dynamically typed. Variables can store values of any type, and a single variable can even store values of different types at different times. If you try to perform an operation on values of the wrong type, say dividing a number by a string, then the error is detected and reported at runtime. Okay, there are plenty of reasons to like static types, but they don't outweigh pragmatic reasons to pick dynamic types for clox. Static type is a ton of work to learn and implement. Skipping it gives you a simpler language and a shorter book. We'll get our interpreter up and executing bits of code sooner if we defer our type checking to runtime. After all, the two languages we'll be using to implement clox are both statically typed. Automatic memory management. High-level languages exist to eliminate error-prone, low-level drudgery. And what could be more tedious than manually managing the allocation and freeing the storage? No one rises and greets the morning sun with a, "I can't wait to figure out the correct place to call free for every byte of memory I allocate today." Oh boy! Oh boy! There are two main techniques of managing memory: reference counting and trace garbage collection, usually just called garbage collection or GC. Ref counters are much simpler to implement. I think that's why Perl, PHP, and Python all started out using them, but over time the limitations of ref counting became too troublesome. All those languages eventually ended up adding a full tracing garbage collector, or at least enough of one to clean up object cycles. So, does Rust use reference counting? Okay. I need to go and reread. Rust uses scopes to keep track of memory. That's why it's difficult to pass a reference to a variable when you declare it inside of a function, inside an inner scope, and then send it out. You have to specify lifetimes and stuff. That's hard. Honestly, that's kind of hard. Eventually, I'm going to have to reread the first couple of chapters of the Rust book, just so I can get the references down in my brain again. I don't even understand it all the way the first time, so I'm going to have to go back and do it again. So, how do I finish this book? That might be one of the next series. It's not the entire Rust book, but part of it. Tracing garbage collection has a fearsome reputation. It is a little harrowing working at the level of raw memory. Debugging a garbage collector sometimes leave you seeing hex dumps in your dreams. But remember, this book is about dispelling magic and slaying those monsters, so we're going to write our own garbage collector. I think you'll find the algorithm is quite simple and a lot of fun to implement. See, this has always just been like black magic to me. How does a language implement a garbage collector? Well, they do reference counting or tracing garbage collection. And reference counting is kind of difficult. So let's see here. Data types. In Lox's little universe, the atoms that make up all matter are built in data types. There are only a few. So Booleans, true and false. I'm not reading all that. Bool. Okay, I didn't know that. George Bool. Which is why Boolean is capitalized. Be kind of cool. Alright, let's see. If I do true, or I do false. What happens if I do true equals false? Doesn't print anything. So if I do print and then, can I do this? True equals false. Oh, I can. Nice. Print true. Print true. Numbers. Lox only has one kind of number, double precision floating points. Okay. So point numbers can also represent a wide range of integers across a lot of territory, while keeping things simple. Okay. Fully featured language has a lot of syntax numbers, like steps, size of octal, all sorts of fun stuff. Basic integer. So we don't have an integer type. Right, so 1, 2, 3, 4, print 1, 2, 3, 4. Print. Is there like a type? This is definitely Pythonic. Yep, no, it doesn't exist. Okay. Print 1, 2, 3, 4, 1, 2, 2, 3. Okay. Strings we already seen in the first example. Alright, so we can do print, boom, print, hello. Yeah, okay. Yep. Even that word character is a trickster. Does it ask a Unicode, a code point, or a grapheme cluster? No idea what these are. Are characters included? Fixed array, can they vary? Nil. There's one last built-in value who's never invited to the party, but always seems to show up, represents no value. It's called null in many other languages. In Lox, you just spell it nil. So if I just do print nil, yeah, okay. I'll distinguish what we're talking about. Lox is nil versus Java RC is null. There are good arguments for not having null in a language, since null pointer errors are the scourge of our industry. If we were doing a statically typed language, it would be worth trying to ban it. A dynamically typed one, though, eliminating this is often more annoying than having it. Yeah. Yeah. One of the other reasons I like Rust. No null values. Genius. If built-in data types and their literals are atoms, and expressions must be the molecules. Most of these will be familiar. Arithmetic. Lox features basic arithmetic operators you know and love from other languages. So if we print 1 plus 2, yeah, okay. Some expressions on either side are the operands. So these are the operands right here. There are 2 of them. These are called binary operators. So yep, this operator is fixed in the middle. These are infix, so like a prefix operator. Say we'd go to here. Do I have a REPL on this system? I guess just closure at this point. Should be thrown straight into a REPL, right? So this is infix, right? So we have 1 plus 2. That doesn't work. Well, it will show it both, and this is closure, so of course I need to wrap it in too, but this does a prefix notation, so it has to be something like that. Yeah. Lisp is pretty cool. When you sit down and actually learn it, it becomes pretty fun to work on. And then postfix, I haven't seen a programming language in the wild that uses postfix. So, yeah, I'm not even going to worry about it. So if, I'll learn that later. Print -12.34. Cool. Both, yep. Comparison and equality, moving along. We have a few more operators that always return a Boolean value. So if we print 1 is less than 2, yep. And then if we print 2 is less than 1, yep. Less than, yep. Okay, okay. Not equal to, I'm going to get that down in my head. So 2 is not equal to 2. That should return false, yep. Even different values. So, like, print hello is equal to 233. I forgot to print hello equal to 233. You know, if there's one thing that I would fix about this REPL, is I would go and implement, I'd save a history and I'd go and implement in this, because it is obnoxious to click up and then, oh, you get the funny. So, yeah. No implicit conversions in this. It's okay with me. The not operator prefix returns false, so if we do print not true, print not true, cool. Yep, 2 logical operators, so we can do, so it's print true and false. Yeah, true and false. Print true or false. Okay. And or, because clox doesn't use for bitwise operators, that would introduce double character forms. That, I mean, he's been doing this his whole life. I can't blame him. And I like I'm a bit of a Python programmer as well, so I'm used to it. The reason and or are like control flow structures is that they short circuit. Not only does and return left, it's false, doesn't even evaluate the right one in that case. Okay, so what happens if I do print true and false and true? Damn it. True and false and true. Okay, but I do print true and true and true. Cool. Precedence and grouping. All these operators have the same precedence and associativity. You'd expect coming from C. When we get to parsing, we'll get way more precise about that. In case of precedence isn't what you want, you can use parentheses to group stuff. So var avg equals max plus min. This is the example from last chapter, divided by 2. Well, I guess I don't really have a max or a min, so let's do var avg equals, let's do 4 plus 2 divided by 2. And then if I just print out avg, print avg, yep. Since they aren't very technically interesting, I cut the remainder of the typical operator menagerie out of our little language. No bitwise shift, modulo, or conditional operators. I'm not grading you, but you'll get bonus points in my heart if you augment your own implementations of clox with them. Bitwise, shift, modulo, or conditional operators. Yeah, okay. Now we're at statements. Where an expression's main job is to reduce a value, statement's job is to produce an effect. Expression's main job is to produce a value. Well, a statement is to produce an effect. Since by definition statements don't evaluate to a value, to be useful, they have to otherwise change the world in some way, usually by modifying some state, reading input, or producing output. Seen a couple kinds of statements already. The first one was print hello world. That was a statement. So a print statement evaluates a single expression and displays the results to the user. making print into a language instead of making it a core library function is a hack, but it's a useful hack for us. It means our in-progress interpreter can start producing output before we implemented all the machinery required to define functions. Look them up by name and call them. Some expression. So the print statement evaluates, produce an effect, like a side effect. This does produce an effect. In fact, it prints to the screen. It's I/O, and I/O is impure. I/O is impure. So this is an expression, because it produces a value, right? That is a value. Is anything being done to the value? Absolutely not. No. And this is a statement. An expression followed by a semicolon produces the expression into An expression followed by a semicolon denotes the expression to statementhood. This is called an expression statement. Okay, so this is the expression. This makes it a statement. It has some effect. The value, this produces a value. And then that produces an effect. If you want to pack a series of statements where a single one is expected, you can wrap them in a block. Blocks also affect scoping, which leads to the next section. You declare variables using var statements. If you omit the initializer, the variable's default values, the variable's value defaults to nil. This is one of those cases where not having nil and forcing every variable to initialize to some value would be more annoying than dealing with nil itself. Okay. Var, I'm a variable. Here is my value. So if I go here, do that, then print I'm a variable. I'm a variable. I'm not going to get this down in my brain. It's going to be a while. Here's my value. And then at var I am nil, print I am nil. Okay. Once declared, you can actually access and assign a variable using its name. You can tell that I tend to work on this book in the morning before I've had anything to eat. Dude. Sometimes. I won't get into the rules for variable scope here, because we're going to spend a surprising amount of time in later chapters mapping every square inch of the rules. In most cases, it works like you would expect coming from C or Java. In most cases. We'll go over it. Control flow. It's hard to write useful programming if you can't skip some code or execute some more than once. That means control flow. In addition to the logical operators we already covered, clox lifts 3 statements straight from C. Okay. There's a little bit of, control flow would be very hard to implement. Not inside of a language. You can get rid of loops with gotos, but that's not. It's not very optimal. I wonder if we're going to do loops. Oh, it looks like we are. Okay. Cool. We already had and or for branching. We could use recursion to repeat code, so that's theoretically sufficient. It would be pretty awkward to program that way in an imperative style language, though. Shim, on the other hand, has no built-in looping constructs. It does rely on recursion for repetition. Smalltalk has no built-in branching constructs and relies on dynamic dispatch for selectively executing code. If statement looks okay. While statement also looks okay. Then we have our C-style for loops. I left do while loops out of locks. They aren't that common. I wouldn't teach you anything I already learned. I like do while loops, and I don't like how they're not in modern programming. Just like, does Rust have a do while loop? It does not have a built-in do while. Oh well, there is just the loop. Yeah. I forgot Rust had that. This loop does the same thing as the previous while loop. Most modern languages also have some sort of for in, for each loop for explicitly iterating over various sequence types. In a real language, that's nicer than the crude C-style for loop we get, but Clox keeps it basic. This is a concession I made because of how the implementation is split across chapters. A for in loop needs some sort of dynamic dispatch in the iterator protocol to handle different types of sequences. But we don't get that until we're done with control flow. We could circle back and add a for in loops later, but I didn't think doing so would teach you anything super interesting. So he thought about implementing it, just didn't do it. Functions. A function call expression looks the same as it does in C. Make breakfast, yep. You can also pass a function call without passing, yep. Unlike, say, in Ruby, parentheses are mandatory in this case. You can leave them off. The name doesn't call function, just refers to it. Things are very fun if you can't define your own functions. In clox, you can do that with fun. I've seen languages that use fn, fun, func, and function. I'm still hoping to discover a funct, functy, or functio somewhere. Yeah, Rust just uses fn. Rust fn. Yep, we use fun. Now's a good time to clarify some terminology. Some people throw around parameter and argument like they're interchangeable, and to many they are. We're going to spend a lot of time splitting the finest of downy hairs around semantics. Let's sharpen our words. From here on out, an argument is an actual value you pass to the function when you call it. So a function call has an argument list. Sometimes you hear actual parameter used for these. So argument is an actual value you pass to a function when you call it. So like if I were to do return sum, if I were to pass 2 and 3 to this, those would be the arguments, I believe. A parameter is a variable that holds the value of the argument inside the body of the function. So thus a function declaration has a parameter list. These often called formal parameters or simply formals. Is a variable that holds the value of the argument inside the body of the function. So A and B would be the parameters, and then let's say this function is called with, let's say return sum. Return sum is called with 2 or 3. Then those would be 2 and 3 would be the arguments, and A and B would be the parameters. If execution reaches the end of the block without hitting return, implicitly returns nil. So node sneaking around looking. That's just how programming. That's just how modern programming languages work. Oh, that ended my repo. Okay. Function closures. These are in Rust. Functions are first class in clox, which means they're real values. They can get a reference to, store variables in, pass around. This works. So fn, add pairs, fun identity just returns itself. Since function declarations are statements, you can declare local variables inside another function. Yep, okay. If you combine local functions, first class functions. So these are functions these are real values that you can get a reference to, store variables and pass around. This works. Identity, add pair. Wait, hold on. How the fuck does that work? Oh, no, that makes sense. Okay. So, basically, the identity function gets called right here, and then this, I'm going to assume this gets evaluated, and that just returns the add pair function straight back. And then these are the parameters, the arguments, sorry, to add pair, and then that gets called. That makes sense. So, that means they're first class. Real values you can just get a reference to and pass around. Okay. Since function declarations are statements, you can declare local variables inside another function. Yeah, they're first class, so they're just variables as well. Like in Rust, they're just addresses. And you can compare function calls. Are these calling the same functions? And I have actually had to use that before when I was programming my genetic programming framework. If you combine local functions, first class functions, and block scope, you run into this interesting situation. So fun return function outside, print outside, var fn equals return function fn, local functions, first class functions, and block scope. I have no idea what's going on. Let's see. Could I do... I'm going to run this. I don't know how to do multi-line comments or multi-line in the repo. Here, inner accesses a local variable declared outside its body in the surrounding function. Is this kosher? No, that's a lot of languages that borrow this feature from Lisp. Now that lots of languages borrow this feature from Lisp, you probably know the answer is yes. For that to work, inner has to hold on to references, and yep, this is a closure. They used to stay around even after the outer function has returned. We call functions that do this closures. In these days, the term is often used for any first-class function, though it's sort of a misnomer if the function doesn't happen to close over any variables. So Peter J. Landon coined the term closure. Yes, he invented damn near half the terms in programming languages. Most of them came out of one incredible paper, the next to 700 programming languages. What is this? (1965). In order to implement these kind of functions, you need to create a data structure that bundles together the function's code and the surrounding variables it needs. He calls this closure because it closes over and holds the variables it needs. Yep, Rust does that. I'm gonna look this up on Google Scholar. As you can imagine, implementing these adds some complexity because we can no longer assume variable scope works strictly like a stack, where local variables evaporate the moment the function returns. As you can imagine, implementing these adds some complexity because we can no longer assume variable scope works strictly like a stack, where local variables evaporate the moment the function returns. We're gonna have a fun time learning how to make these work correctly and efficiently. It's not a black box, and though it definitely seems like it. Classes. Since clox has dynamic typing, lexical, roughly block scope, and closures, it's about halfway to being a functional language. But as you see, it's also about halfway to being an object-oriented language. Both paradigms have a lot going for them, so I thought it was worth covering some of each. Since classes have come under fire for not living up to their hype, let me first explain why I put them into locks in this book. There are really two questions. Why might I want any language to be object-oriented? Now that object orientators like Java have sold out and only play arena shows, it's not cool to like them anymore. Why would anyone make a new language with objects? Isn't that like releasing music on an 8-track? It is true that the all-inheritance, all-the-time binge of the 90s produced some monstrous class hierarchies, but object-oriented programming is still pretty rad. Billions of lines of successful code could have been written in OOP languages, shipping millions of apps to happy users. Likely the majority of working programmers today are using an OOP. They can't all be that wrong. In particular, for dynamically typed languages, objects are pretty handy. We need some way of defining compound data types to bundle blobs of stuff together. If we can also hang methods off of those, then we avoid the need to prefix all of our functions with a name of the data type they operate on to avoid colliding with similar functions for different types. And say racket, you end up having to name your functions like hash-copy to copy a hash name, or vector-copy to copy a vector, so they don't step on each other. Methods are scopes of the object, so that problem goes away. So this is how like Rust and Haskell have their own versions of traits and IMPL statements. And so that's how they avoid on stepping those problems, because you can just go and implement the copy trait for a specific data type. Rust copy trait. Right, like clone, not copy, clone. So let's say I have a struct here, and I need a clone, and then I can go and implement this if I need to, and then I can run clone on my struct. Or I can just use derive clone, and then it can do it automatically using proc macros. Well, using macros. I don't know what type of macro I might use. I like 3 in Rust. Why is locks object-oriented? I could claim objects are groovy, but still out of scope for the book. Most programming language books, especially ones that try to implement a whole language, leave objects out. To me, that means the topic isn't well covered. With such a widespread paradigm, that omission makes me sad. Given how many of us spend all day using OOP languages, it seems the world could use a little documentation on how to make one. As you'll see, it turns out to be pretty interesting. Not as hard as you might fear, but not as simple as you might presume either. When it comes to objects, there are actually 2 approaches to them, classes and prototypes. Classes came first and are more common thanks to C++, Java, C#, and friends. Prototypes were a virtually forgotten option until JavaScript accidentally took over the world. In class-based languages, there are 2 core concepts, instances and classes. Instances store the state for each object and have a reference to the instance's class. Classes contain the methods and inheritance chain. To call a method on an instance, there is always a level of indirection. You look up the instance's class, and you find the methods there. In a statically typed language like C++, method lookup typically happens at compile time based on the static type of instance. Prototypes, in which behavior reuse is performed by a process of reusing existing object service prototypes. Inheritance. Okay, I guess I'll learn about prototypes later. Two core concepts: instances and classes. Instances store the state for each object and have a reference to the instance's class. Okay. Okay. Static language C++. Most method lookup typically happens at compile time based on the static type of the instance, giving you static dispatch. In contrast, dynamic dispatch looks up the class of the actual instance at runtime. This is how virtual methods in statically typed languages and all methods in dynamically typed language like clox work. I don't really know what a virtual method is. ChatGPT! What is a virtual method? Declared in base class, it can be overridden. Not what I need. There's a member function that is declared within a base class and is redefined to be overwritten. Okay, so they just need to be overwritten. Prototype-based languages merge these two concepts. There are only objects, no classes, and each individual object may contain state and methods. Objects can directly inherit from each other or delegate to in prototypal lingo. So what is this? Benedict, meat equals ham, bread equals English muffin, has class, brunch. Which inherits from breakfast. In practice, the line between class-based and prototype-based languages blurs. JavaScript's constructor function notion lets you push pretty hard towards defining class-like objects. Meanwhile, class-based Ruby is perfectly happy to let you attach methods to individual instances. This means in some ways prototypal languages are more fundamental than classes. They're really neat to implement because they're so simple. Also, they can express lots of unusual patterns that classes steer you away from. But I've looked at a lot of code written in prototypal languages, including some of my own devising, the Finch programming language. Cool. What people generally do with all the power for them, they use it to reinvent classes. I don't know why that is, but people naturally seem to prefer class-based style. Prototypes are simpler in the language, but they seem to accomplish that only by pushing the complexity onto the user. So for locks, let's say we use the trouble and bake classes right in. Okay. Larry Wall, Perl's inventor, prophet, calls this the waterbed theory. Some complexity is essential and can be eliminated if you push it down in one place, it swells up in another. Prototypal languages don't so much eliminate complexity of these classes as they do make the user take that complexity by building their own class-like metaprogramming libraries. Okay, classes and locks. Enough rationale, let's see what we actually have. Classes encompass a constellation of features in most languages. For locks, I've selected what I think are the brightest stars. You can declare a class and methods like so. So class breakfast, we cook. Eggs are frying, he does do this before he eats in the morning. Serve. The body of the class contains its methods. They look like function declarations, but without the fun keyword. The class declaration is executed, Lox creates a class object and stores that in a variable named after the class, just like functions. Class is our first class in Lox. They're still just as fun though. Store in a variable, pass it to some functions. So you can pass the class address type to a function directly. Next, we need a way to create instances. We can add some sort of new keyword. To keep things simple in Lox, the class itself is a factory function for instances. Call a class like a function that produces a new instance of itself. Okay. I like the Rust factory functions. Rust factory functions. And how they are explicit. Instantiation and initialization. Classes that only have behavior aren't super useful. The idea behind object-oriented is encapsulating behavior and state together. To do that, you need fields. Lox, like other dynamic type languages, you freely add properties onto objects. So breakfast.meat, yep. Adding to a field creates if it doesn't already exist. If you want to access a field or method of the current object from within a method, you gotta use good old this. Alright, serve who, print enjoy your this.meat, this.bread, who. Part of encapsulating data within an object, ensuring the object is in its balanced state when it's created. To do that, you can define an initializer. If your class has a method named init, it is called automatically when the object is constructed. Any parameters passed to the class are forwarded to its initializer. Class, okay, hold on. If your class has method named init, it is automatically, it is called, okay. Part of encapsulating data within an object, ensuring the object is in a balanced state when it's created. So that you can define an initializer. If your class has a method named init, it is called automatically when the object is constructed. Okay, cool. So that is, I can see it has a built-in factory function that you can call. But it doesn't do anything. Well, at least in C++, don't know about C. But here, you define an init function, and then it does it runs it automatically. Var, bacon, and toast. Okay, I like that. Inheritance. Every object-oriented language lets you not only define methods, but reuse them across multiple classes or object. For that, Lox supports single inheritance. When you declare a class, you can specify a class inheritance from a less than operator. So class brunch inherits from breakfast. Drink. How about a Bloody Mary? Why the less than operator? And if I can introduce a new keyword like extends. Lox doesn't use colon for anything else, so I didn't want to reserve that either. Instead, I took a feature from Groovy and used the less than. If you know any type theory, you'll notice that it's not a totally arbitrary choice. Every instance of a subclass is an instance of a superclass too. But there may be instances of the superclass. I don't really feel like reading this. Here, branch is the derived class or subclass in bracket. Yep. Every method defined in superclass also has an available. In subclasses, even the init method gets inherited. In practice, a subclass usually wants to define its own init method too. The original one also needs to be called so that the superclass can maintain its state. We need some way to call a method on our own instance without hitting our own methods. Lox is different from C++, Java, and C#, which do not inherit constructors, but similar to Smalltalk Ruby, which do. As in Java, you use super for that. So, super init. Alright. I'm surprised it's not like just super without the init, but you need to do that. That's about it for object orientation. I try to keep the feature set minimal. The structure of the book did force one compromise. Lox is not a pure object-oriented language. In a true OOP language, every object is an instance of a class, even primitive values like numbers and booleans. Because we don't implement classes until well after we start working with the built-in types, that would have been hard. So values of primitive types aren't real objects in the sense of being instances of classes. They don't have methods or properties. If I were trying to make Lox a real language for users, I would want to fix that. Okay. Yeah, we're almost done. So it doesn't have real methods or properties, so does that mean I can cast an int to a string in this? That's a problem. That'd be an issue. We're almost done. That's the whole language. So all that's left is the core standard library. The set functionality that is implemented directly in the interpreter and that all user-defined behavior is built on top of. This is the saddest part of Lox. The standard library goes beyond minimalism and veers close to outright nihilism. For the sample code in the book, we only need to demonstrate that code is running and doing what it's supposed to do. For that, we already have the built-in print statement. Later, we start optimizing. We'll write some benchmarks and see how long it takes to execute code. That means we need to track time. We'll define one built-in function clock that returns the number of seconds since the program started, and that's it. I know, right? It's embarrassing. So it'll be like clock. That's it. This is meant to more talk about like how languages are implemented, and we'll get a hint of standard library, but it's going to be talking about lexical analysis, parsing, scanning. And those are the same thing. Well, some of them are the same thing. IRs, transpiling. If you want to turn locks into actually useful language, the very first thing you do is flesh it out. String manipulation, trig functions, file I/O, networking, heck, even reading input from the user would help. We don't need any of that for this book, and adding it wouldn't teach you anything interesting, so I left it out. Don't worry, we'll have plenty of exciting stuff in the language to keep us busy. Okay, so I'm gonna read, the challenges are here, but I'm gonna read the design note as well. Locks has both expression and statement. Some languages omit the latter. They treat declarations and control flow constructs as expressions too. These everything is an expression languages tend to have functional pedigrees. Yep, Lisp, Haskell. Yep. Okay. I have no idea what CoffeeScript is. Looks kind of functional. To do that, for each statement-like construct in the language, you need to decide what value it evaluates to. Some of those are easy. An if expression evaluates the result of whichever branch is chosen, like switch. The variable declaration evaluates to the value of the variable. The block evaluates to the result. The last expression in a sequence. Some get a little stranger. What should a loop evaluate to? A while loop and CoffeeScript evaluates to an array containing each element. The body's evaluated that can be handy or a waste of memory if you don't need the array. You also have to decide how these statement-like expressions compose with other expressions. You have to fit them into the grammar's precedence table. For example, Ruby allows puts 1 plus if true, then 2, else 3, and plus 4. What you expect is what your users expect. How does this affect how you design the syntax of your statements? Note that Ruby has an explicit end to tell when the if statement is complete. Without the plus 4 would likely be parsed as part of the else clause. Turning every statement to an expression forces you to answer a few hairy questions like that. In return, you eliminate some of the redundancy. C has both blocks for sequencing statements and a comma operator for sequencing expressions. It has both the if and the question mark colon conditional operator. When everything was an expression in C, you could unify each of those. Languages that do away with statements usually also feature implicit returns. A function automatically returns whatever value its body evaluates to without the need for some explicit return syntax. For small functions and methods, this is really handy. In fact, many languages that do have statements have added syntax like the big arrow to be able to define functions whose body is the result of evaluating a single expression. Rust kind of does that. By making all functions work that way can be a little strange. If you aren't careful, your function will leak a return value even if you only intend to produce a side effect. In practice, though, users of these languages don't find it to be a problem. For locks, I gave it statements for I picked a C-like syntax for familiarity's sake, and trying to take the existing C statement syntax and interpret it like expressions gets pretty weird fast. It's weird pretty fast. Okay. That went in one ear and out the other. So I watch my entire videos back when I'm editing. So this will be I'm going to read through this while I'm editing, and then I'll understand what's going on. Let's look at these challenges. So write some sample locks programs and run them. You can use the implementations of locks in my repository. Try to come up with edge case behavior I didn't specify here. What do you expect? Why or why not? So I have... I should have read a little bit more. Okay. If I just... Okay, so let's see. he has the test right here. And then let's say we go to the if, and then let's look at if dialogs. So if I go here and I do build here, and I go build clox, then I do test if.lox, that'll run. Okay, so I just need to create a simple file, make dir, just call it Rowan, hx Rowan, and then we'll do run, we'll just do test.lox. Try and come up with some edge case behavior. So if I do if true, what happens if I do if nil? If nil, think yes. Else, print no. Build clox, Rowan test.lox. Well, I guess that's edge case. Is what does nil, and nil results to false. What happens if I do something like print 1, 2, 3 plus 4, 5, 6? I don't remember seeing that. Okay. So, in terms of edge case right here, the string function does, I don't really know what to expect, honestly, so I guess no. I guess I didn't do what to expect because I didn't expect anything. I didn't expect to be able to add strings. I didn't know if it was implemented or not, if concatenation like that worked. But that's how it works here, and I didn't know that nil would evaluate to false. I just didn't expect it to. I didn't expect it to evaluate to true either. I just really didn't know. So there's some edge case right there that they didn't mention, that Robert Nystrom didn't mention. Expression produces some value, and then the statement produces an effect from it. Okay. Yeah, that's well, I found some edge cases that were not specified. Here, let's see. If I go into a for loop, yeah, wait, hold on. All these variables are these are all there's no difference between decimals, so there's also no n++, so that's annoying. Yeah, okay. Can I... Yep. So that evaluates to false. Yeah, I remember talking about that. Can you do operands must be two numbers or strings. Okay. What are these are comments, right? Yeah, okay. Those are comments. It does talk about operands somewhere in here. Okay, yeah. So that's an edge. That's another edge, is being asked, adding two different types together, which in some languages true evaluates to 0. I wonder, if I do, I don't have IPython installed, so if I do true plus 1, true plus 1, that equals 2. So, yeah. Okay. I was kind of expecting true to be equal to 0 and false. Oh, sorry, true equal to 1 and false equal to 0 in clox, but that's not how it works. This informal introduction is a lot unspecified. Let's have our open question about the language syntax and semantics. What do you think the answer should be? So hx rowan questions.txt. Write some sample looks. There's several open questions about the language syntax and semantics. I'll list maybe I'll find 3 questions. Why do built-ins not need parentheses? Because we aren't setting up functions yet. Functions will come later. And this built-in will be good enough for now. So, do we get multi-line comments? I honestly think we should. I think multi-line comments are very important in a language. But I don't think we're going to get them in this one. Keep it simple. How does the implicit factory function work? Well, it's not really declaring any variables inside of it, so I'm going to guess that it just leaves the variables inside of the class as nil, and then will just return you that object. Why do we have to explicitly call super init? Instead of super. I'm going to guess it's just style. And then I'm going to say yes, because it's like this in other languages. Yeah. Clox is a pretty tiny language. What features do you think it's missing that would make it annoying to use for real programs? Oh boy. This is question number 2. 3. So it would be annoying to... Well, it doesn't have any of these. It doesn't have any of these. It doesn't have any of those. So that would be nice to have. It's going to have garbage collection. Like for real programs. There's no standard library. No string manipulation. Trig functions, file IO. Yeah, well, there's no modulo. No remainder function. As it says, there's no for each. That's something that is also annoying. I'm guessing it's going to have arrays in it and such. Yeah, like how user implements own array list vector. That could be annoying. That's a big assumption though, so we're going to do it later. So that could be annoying, having to implement your own data structures. Is there any, like, yeah, no file IO. Yeah, that's all I got. Let's go and look at let's go and see what he thinks. Chapter 3. I've written plenty, so we can test. Here's another. Global variable in the function before it's defined. Doesn't mean to say something is an error. Runtime error, compilation error. Okay, yeah. What kind of expressions are allowed when a superclass is defined? Yeah, like private Yep. What happens if you declare two classes or functions of the same name? Can a class inherit from something that isn't a class? Can you reassign to the name that is bound by a class or function declaration? The big ones are list-arrays. You can build your own linked list, but there's no way to create a data structure that stores a contiguous series of values that can be accessed in constantine and user code. That has to be baked into the language with some core library. Yeah, I was thinking about that. Some mechanism for handling runtime errors along the lines of exception handling. Okay, also no break or continue for loops, no switch. Yeah. Okay, cool. Bye-bye.